To minimize wiring problems, firstly, plan ahead. Always inspect the plans thoroughly before starting work to avoid surprises or errors during installation. Secondly, follow code requirements. Strictly adhere to applicable electrical codes such as the National Electrical Code or Canadian Electrical Code to ensure safety and compliance. Thirdly, use high-quality materials. Invest in reputable brands and avoid cheap or inferior components. Fourthly, keep it tidy. Maintain a clean and organized workspace to minimize mistakes and facilitate troubleshooting. Fifthly, label wires consistently. Use color coding or marking tape to clearly identify wires and circuits for easy identification. Sixthly, secure connections. Use appropriate connectors, for example, crimps, wire nuts, and torque them to specifications to prevent loose connections. Seventhly, test early and often. Perform voltage and continuity checks throughout the installation process to identify potential problems before they become major issues. When it comes to grounding practices, firstly, keep grounding wires short. Minimize the length of grounding wires to reduce resistance and improve grounding effectiveness. Secondly, secure grounding connections. Ensure that grounding wires are tightly connected to all metal boxes, devices, and equipment. Thirdly, use copper grounding rods. Install copper grounding rods to a depth specified by code to provide a reliable ground connection. For circuit management practices, firstly, balance circuits. Distribute loads evenly across circuits to prevent overloads and circuit trips. Secondly, use proper wire gauges. Choose wire gauges that are appropriate for the current draw and circuit length. Thirdly, install ground fault circuit interrupters and arc fault circuit interrupters. Use ground fault circuit interrupters and arc fault circuit interrupters as required by code to provide added safety protection. Regarding device and fixture installation practices, firstly, install devices correctly. Ensure that devices are properly oriented and secured in boxes. Secondly, use proper spacing. Maintain appropriate spacing between devices and wires to avoid interference or damage. Thirdly, secure light fixtures. Use appropriate mounting hardware and torque fixtures to specifications to prevent vibration and loose connections. For troubleshooting and inspection, firstly, use a multimeter. Invest in a quality multimeter to identify voltage, current, and continuity issues. Secondly, inspect boxes thoroughly. Check for missing screws, loose connections, and damage before installing devices. Thirdly, test switches and outlets. Verify that switches and outlets are functioning properly before closing up boxes. Finally, perform a final walkthrough. Conduct a thorough inspection of the completed installation to ensure that everything is installed correctly and to identify any potential problems. These practices will help reduce troubleshooting time, improve safety, and ensure code compliance in multifamily residences. A common problem is voltage drop, which occurs when the voltage at the end of a circuit is significantly lower than the source voltage. This can cause lights to dim, appliances to function improperly, and even overheating of wires. To mitigate voltage drop, firstly, use the correct wire gauge. Use larger wire gauges for longer circuits or circuits with high current draw. Refer to National Electrical Code Table 310.15 for ampacity ratings and voltage drop calculations. Secondly, reduce circuit length. Shorter circuits experience less voltage drop. If possible, divide long circuits into multiple shorter circuits. Thirdly, balance the load. Ensure that the load is evenly distributed across all phases in a three-phase system to prevent voltage imbalances. Another frequent issue is overheating. Overheating can occur due to overloaded circuits, loose connections, or improper wiring. Overheating can damage insulation, melt wires, and even cause fires. To prevent this, firstly, avoid overloading circuits. Ensure that the load on each circuit does not exceed the maximum ampacity of the wire and breaker. Use appropriate size breakers for the wire gauge. Refer to National Electrical Code Table 310.16 for allowable ampacities of insulated conductors. Secondly, tighten connections. Ensure that all connections are tight and secure. Loose connections can cause arcing and heat buildup. Use a torque screwdriver to tighten connections to the manufacturer's specifications. Thirdly, use proper wiring methods. Follow proper wiring methods and techniques to avoid damaging the insulation of the wires. Avoid sharp bends and kinks in the wires. Ground faults are a safety hazard that can cause electric shock. A ground fault occurs when a hot wire comes into contact with a grounded surface or equipment. To protect against ground faults, firstly, install ground fault circuit interrupters. Install ground fault circuit interrupters in areas where water is present, such as bathrooms, kitchens, and outdoor locations. Ground fault circuit interrupters trip when they detect a ground fault, cutting off the power and preventing electric shock. Secondly, maintain proper grounding. Ensure that all metal parts of the electrical system are properly grounded. This provides a path for fault current to flow back to the source, tripping the breaker and preventing electric shock. Arc faults can cause fires. An arc fault is an unintentional electrical discharge between two or more conductors. Arc faults can occur due to damaged insulation, loose connections, or corroded wires. To prevent arc faults, firstly, install arc fault circuit interrupters. Arc fault circuit interrupters trip when they detect an arc fault, cutting off the power and preventing fires. Arc fault circuit interrupters are required in many areas of the home, such as bedrooms and living rooms. Secondly, use proper wiring methods. Follow proper wiring methods and techniques to avoid damaging the insulation of the wires. Avoid using staples or nails to support wires, as they can damage the insulation. Electrical noise can interfere with the operation of electronic devices. Electrical noise can be caused by electromagnetic interference or radio frequency interference. To reduce electrical noise, firstly, use shielded cables. Use shielded cables to protect sensitive circuits from electromagnetic interference. Secondly, install filters. Install filters on power lines to reduce radio frequency interference. Improper labeling can lead to confusion and mistakes. To ensure proper labeling, firstly, label all circuits. Label all circuits in the electrical panel with a clear and concise description of what they serve. Use a permanent marker or label maker to create durable labels. Secondly, use color coding. Use color coding to identify different types of wires. For example, black wires are typically used for hot wires, white wires are typically used for neutral wires, and green wires are typically used for grounding wires. Poor workmanship can lead to a variety of problems, including loose connections, damaged insulation, and incorrect wiring. To ensure quality workmanship, firstly, train your crew. Provide your crew with thorough training on proper wiring methods and techniques. Emphasize the importance of safety and attention to detail. Secondly, inspect their work. Regularly inspect your crew's work to identify and correct any mistakes. Provide feedback and guidance to help them improve their skills. By implementing these tips and wiring practices, you can minimize problems, improve safety, and ensure the long-term reliability of the electrical systems in multifamily residences. Remember that regular inspections and maintenance are essential for preventing problems and ensuring the continued safe operation of the electrical system. Following electrical codes is crucial for the safety and compliance of electrical installations. The National Electrical Code, also known as National Fire Protection Association 70, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. The code covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is updated every 3 years to reflect the latest advances in technology and safety practices. Firstly, understand the scope of the National Electrical Code. The National Electrical Code applies to virtually all electrical installations in residential, commercial, and industrial buildings. It does not apply to the wiring of vehicles, aircraft, or ships, nor does it apply to the wiring of telephone, telegraph, or data communication systems. Secondly, familiarize yourself with the organization of the National Electrical Code. The National Electrical Code is organized into 9 chapters, each covering a specific area of electrical installations. Chapter 1 covers general requirements such as definitions, wiring methods, and conductor requirements. Chapter 2 covers wiring and protection, including overcurrent protection, grounding, and surge protection. Chapter 3 covers wiring methods and materials, including conduit, cable, and raceways. Chapter 4 covers equipment for general use, including appliances, lighting fixtures, and motors. Chapter 5 covers special occupancies, such as hazardous locations, healthcare facilities, and recreational vehicles. Chapter 6 covers special equipment, such as elevators, cranes, and electric signs. Chapter 7 covers special conditions, such as emergency systems, fire alarm systems, and communications systems. Chapter 8 covers communications systems such as telephone, data, and cable television systems. Chapter 9 contains tables and examples for calculating wiring sizes and other electrical parameters. Thirdly, stay up to date with the latest edition of the National Electrical Code. The National Electrical Code is updated every 3 years, so it is important to stay up to date with the latest edition. You can purchase a copy of the National Electrical Code from the National Fire Protection Association or from other sources. You can also find the National Electrical Code online. Fourthly, use the National Electrical Code as a guide. The National Electrical Code is a comprehensive guide to safe electrical installations. Use it as a reference when planning, designing, and installing electrical systems. Fifthly, consult with a qualified electrician. If you are not familiar with the National Electrical Code, it is best to consult with a qualified electrician. A qualified electrician can help you understand the code requirements and ensure that your electrical installations are safe and compliant. When planning your wiring, consider these factors. Firstly, determine the load requirements. Calculate the total load that each circuit will need to carry. This includes the amperage of all the lights, appliances, and other equipment that will be connected to the circuit. Secondly, select the appropriate wire size. Choose a wire size that is large enough to carry the load without overheating. Refer to National Electrical Code Table 310.16 for allowable ampacities of insulated conductors. Thirdly, choose the appropriate overcurrent protection. Select a circuit breaker or fuse that is sized to protect the wire from overcurrent. The overcurrent protection should not exceed the ampacity of the wire. Fourthly, plan the layout of the circuits. Plan the layout of the circuits so that the load is evenly distributed. Avoid overloading any one circuit. Fifthly, choose the appropriate wiring method. Select a wiring method that is appropriate for the location and type of building. Common wiring methods include non-metallic sheath cable, armored cable, and conduit. Sixthly, install the wiring according to code. Install the wiring according to the National Electrical Code and any local codes. Be sure to follow all safety precautions. Seventhly, test the wiring. After the wiring is installed, test it to make sure that it is working properly. Use a multimeter to check for voltage, continuity, and ground faults. Grounding is an essential part of electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the breaker and preventing electric shock. Grounding also helps to reduce electrical noise. Firstly, understand the purpose of grounding. The purpose of grounding is to provide a low impedance path for fault current to flow back to the source. This allows the overcurrent protection device, such as a circuit breaker or fuse, to quickly trip and energize the circuit. Secondly, use a grounding electrode system. A grounding electrode system is a network of interconnected grounding electrodes that provide a connection to the earth. Common grounding electrodes include ground rods, ground plates, and metal underground water pipes. Thirdly, bond all metal parts. Bond all metal parts of the electrical system together, including metal boxes, conduit, and equipment enclosures. This creates a lower impedance path for fault current to flow back to the source. Fourthly, use a grounding conductor. Use a grounding conductor to connect all of the grounded metal parts to the grounding electrode system. The grounding conductor should be sized according to the National Electrical Code. Fifthly, test the grounding system. Test the grounding system to make sure that it is working properly. Use a ground resistance tester to measure the resistance of the grounding electrode system. Maintaining electrical systems involves keeping the system in good working order and preventing problems. Regular maintenance can help to extend the life of the electrical system and prevent costly repairs. Firstly, inspect the electrical system regularly. Inspect the electrical system regularly for any signs of damage or wear. Look for loose connections, frayed wires, and corroded components. Secondly, tighten connections. Tighten all loose connections. Loose connections can cause arcing and heat buildup, which can lead to fires. Thirdly, replace damaged components. Replace any damaged components, such as frayed wires, cracked receptacles, and broken switches. Fourthly, clean the electrical system. Clean the electrical system regularly to remove dust, dirt, and debris. Dust and dirt can accumulate on electrical components and cause them to overheat. Fifthly, test the electrical system. Test the electrical system regularly to make sure that it is working properly. Use a multimeter to check for voltage, continuity, and ground faults. Remember to prioritize safety in all electrical work. Always to energize the circuit before working on it. Use appropriate personal protective equipment such as gloves and safety glasses. Follow all safety precautions. The first step in troubleshooting electrical problems is to identify the problem. This may involve talking to the customer, observing the symptoms, and using test equipment. Secondly, gather information. Gather as much information as possible about the problem. This includes the type of equipment that is affected, the location of the problem, and the conditions under which the problem occurs. Thirdly, use test equipment. Use test equipment, such as a multimeter, to diagnose the problem. A multimeter can be used to measure voltage, current, and resistance. Fourthly, isolate the problem. Isolate the problem to a specific circuit or component. This may involve disconnecting circuits or components one at a time until the problem is found. Fifthly, repair the problem. Repair the problem by replacing damaged components, tightening loose connections, or correcting wiring errors. Sixthly, test the repair. Test the repair to make sure that the problem has been fixed. Use test equipment to verify that the circuit is working properly. When choosing materials for electrical installations, select the right type of wire for the application. Different types of wire are designed for different applications. For example, non-metallic sheathed cable is commonly used for residential wiring, while conduit is used for commercial and industrial wiring. Secondly, choose the correct size of wire. The size of the wire must be large enough to carry the load without overheating. Refer to National Electrical Code Table 310.16 for allowable opacities of insulated conductors. Thirdly, choose the correct type of conduit. Different types of conduit are designed for different applications. For example, rigid metal conduit is used for corrosive environments, while electrical metallic tubing is used for dry locations. Fourthly, choose the correct type of box. Different types of boxes are designed for different applications. For example, metal boxes are used for fire-rated walls, while non-metallic boxes are used for damp locations. Fifthly, choose the correct type of connectors. Different types of connectors are designed for different applications. Use connectors that are rated for the type of wire and conduit that you are using. In general, when doing electrical work, do not work on live circuits. Always to energize the circuit before working on it. Use appropriate personal protective equipment, such as gloves and safety glasses. Follow all safety precautions. Only qualified electricians should perform electrical work. Electrical work can be dangerous if it is not done properly. If you are not qualified to perform electrical work, hire a qualified electrician. Remember that thorough planning, adherence to codes, and attention to detail are key to successful and safe electrical installations in multifamily residences. Use these tips to equip your crew with best practices.